Hey, welcome back, class. This is week 6 video. I hope you all are doing well. To start off with, as always, let's go over what your assignments are for this week. So for my in-person students, I want all of you to be doing the 1-4 practice problems. Okay, and what 1-4, I'm actually taking 1-4, 1-5, and 1-6 inside of our textbooks and putting it into one. So rather than spending 3 weeks on basically the same concept, which is dividing fractions, we're just going to focus on the most important stuff just for this week. Now for my virtual students, I also want you to be doing the 1-4 practice, and you are also going to be doing the gallery walk divide fraction problems, because my in-person students are going to be doing that activity on either Tuesdays or Friday. So everyone's going to be doing the same exact thing. Now, you all will see something a little bit different that you may not have seen before in any of your classes, and it's called Khan Academy. And I'll go over it in more detail later on. But basically, what it is that it's a review of dividing fractions. It gives you videos and practice problems, so it's a good way for you to not only do things on Schoology, but to see and hear from another educator how to divide fractions, and maybe it'll help you a little bit more. Okay, so let's hop into today's lesson. So let's start off with a warm-up. So there's 2 problems here that I would like you guys to try, and it deals with the concept that we learned last week, which was multiplying fractions. For the first one, it says 4/5 times 10, and the second one says 3 1/2 times 3 1/3. So before I set you loose so that you can try them on your own, some things I want you to remember. The first thing you always want to do when you're multiplying fractions is to line up your fractions. Now for this first one, you'll notice that 10 isn't a fraction. So in order to multiply it by 4/5, you want to make it into a fraction. And the way we do that is we add a 1 underneath of it, because 10 divided by 1 is just 10, so it doesn't change the number. Now over here, our fractions are lined up, but technically they're mixed numbers, and we don't want to work with mixed numbers when we're multiplying. So what we need to do first is you need to change both of these mixed numbers into improper fractions. And the way you do that, if I have 3 1/2, I'll do the first one for you. You multiply the denominator by the whole number, which is 3 times 2 is 6, and then you add the numerator, which would be 7. So 3 1/2 as an improper fraction would be 7/2, or 7/2. So use that information to try to solve these 2 problems. Pause the video and we'll go over the answer together. Okay, so hopefully you gave yourself enough time. Let's go over the answer together. So for this one, our fraction is lined up, both of them. So that means we can multiply straight across. 4 times 10 gives you 40. And then 5 times 1 gives you 5. Now this is an improper fraction. You don't want to leave it this way. But one other thing to think about, and I think I said this in the last video, fractions are just division. So if this is 40/5, what it's saying is 40 divided by 5, which is what? 8. So 40 divided by 5 gives you 8. Another way you could have figured this out is you could have divided the bottom number into the top number. 5 into 40, which still would give you the same answer, which is 8. Because 8 times 5 is 40 with a remainder of 0. So let's try the second one. We already changed the first mixed number into an improper fraction, which was 7/2. So now let's change the second mixed number into its improper form. 3 times 3 is 9, plus 1 is 10. So that means I get a 10, and your denominator does not change. It stays a 3. Now my fractions are lined up, and I can multiply straight across. 7 times 10 gives you 70, And then 2 times 3 gives you 6. So this one's not as easy to see as what we had over here, 40 divided by 5. 70 divided by 6 isn't going to be an even number. So what we're going to have to do is we want to divide 6 into 70 like we did over here. 6 divided by 70. So 6 times what gets me really close to 7? 1. 6 times 1 is 6. 7 minus 6 gives you 1. Bring down your 0. Now you have 10. 6 times what gets me really close to 10? Well, 6 times 1 is 6, and 6 times 2 is 12, and that's too much, so we only have to use 1 again. 6 times 1 is 6. Well, 10 minus 6 gives you 4, which is your remainder. Now, if you remember from last week, what we said is the trick that you can use is you take your answer, which is 11, and you write that nice and big. And then you take your remainder, which was 4, you put that on top, and your divisor, the number you divided by, goes on the bottom. So far we have 11 and 4/6. Now I want you to think about this. You always want to try to simplify your fraction to the smallest it can be. So 4/6 can be simplified. Is there a number that goes into both 4 and 6 evenly? 2. They're both even numbers, so 2 can go into 4 and 2 can go into 6. 2 times what gives you 4? 2. And 2 times what gives you 6? 3. So your most simplified answer would be 11 and 2/3. And that's your answers. Okay, so let's talk about dividing fractions now. Dividing fractions isn't much different than multiplying fractions. So if it made sense for you before, in the last video when we were multiplying fractions, hopefully this time it's just going to be a little bit of a review. There's just one little tweak that we have to do when we're dividing fractions, and that tweak is called a word right here, which is reciprocal. Hopefully you've heard the word before, but the basic definition I can give you what a reciprocal is it's the flipped upside down form of a fraction. And if it's a mixed number, once you change it to an improper fraction, the reciprocal is it being flipped. So here's an example. If I have 2/5, that's my fraction, and I say, what's the reciprocal of that? The reciprocal is the flipped version of it, which is 5/2, or 5/2. So the original is 2/5, we flipped it, it's 5/2. That's the reciprocal. And the reason we want to know this is because we use the reciprocal in order to divide our fractions. Okay? So let's look at these real quick. Let me scoop me over top. Let's find the reciprocal of these numbers right here. Oops. Let's try that again. So this first one's a 5. 5, remember, we can make it as a fraction by saying 5/1. So the reciprocal of that, what's the flipped version of 5/1? 1/5. So 1/5 is the reciprocal of 5. Let's try this one. It's 2/3. So if it's 2/3, the reciprocal of that, so 2/3, is 3/2, 3/2. All we did is we flipped it. That's it. Let's try this one. 3 and 2/5. So that's a little bit more tricky. You can't just say the reciprocal is 3 and 5/2 because that 3 needs to be involved too. So 3 and 2/5, in order to find the reciprocal of it, we need to change it to an improper fraction and then flip it. Let's change it. 5 times 3 is 15, plus 2 is 17. So the improper form is 17/5, right? Now we can get the reciprocal and flip it which means it is 5/17. So the reciprocal of 3 2/5 is 5/17. Let's try the last one. 4 3/7. Again, you want to change it to an improper fraction first. 7 times 4 is 28. 28 plus 3 is 31. So the improper form is 31, and your denominator stays the same, sevenths. Now what's the reciprocal? Flip it. The reciprocal is 7/31. That's it. So whenever I say what's the reciprocal of insert answer there, you just flip it, and that's what you do. Okay, so keep that in mind because we're going to use this inside dividing fractions next. So there's a very corny video that I like to use by Number Rocks that's called Keep Change Flip, right? Or you may hear Keep Chewbacca Fly. And what that means is that when you divide fractions, you always want to keep the first fraction the same, change the division sign to multiplication, and then flip the last fraction, or give me the reciprocal. Okay, so let's watch a video, and hopefully this makes a little bit sense, and then we'll practice it.
To divide by a fraction, here's a 10. Keep, change, flip. To divide by a fraction, here's a 10. Keep, change, flip. To divide 1/2 by 1/6. Keep, change, flip. 1 times 6 is 6 and 2 times 1 is 2. It's an improper fraction, so we're not through. Divide 6 by 2 and the quotient is 3. Keep, change, flip. It's all that you need. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To divide 2/5 by 1/5. Keep, change, flip. 2 times 5 is 10, and 5 times 1 is 5. It's an improper fraction, so you need to divide. 10 divided by 5 equals 2. When we divide by fractions, this is what we do. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip.
Keep, change, flip.
Keep, change, flip may seem to work magically, but it can be explained mathematically. With the number 10, we can divide by 2, and that will leave 5 in each group. Or we can find that 5 through a different path by multiplying 10 by 2 flipped to 1/2. It's the trick that never fails, called keep, change, flip. It's real mathemagic, so use this tip.
We understand with these problems we love, because we know division means has how many groups of?
Let's explore that thought. How many groups of fourths does 1/2 got? 2/4 fit into 1/2 perfectly, and we found the quotient mentally. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip. To divide by a fraction, here's a tip. Keep, change, flip.
So I know that video was pretty corny, but I do like it because it gets you in the habit of thinking of keep, change, flip, and it's gonna stick in your head for a while because I'll bring it back up throughout the year. But also it brings up how division, really all it is that you're trying to figure out how many groups of something you're looking for. Okay, so let's look at this first example and we'll apply keep, change, flip, or keep Chewbacca fly. Mr. Roberts has a board that is 3 feet long. He plans to cut the board into pieces that are 3/4 foot long to build a set of shelves. How many shelves can he make? So there's a long piece of wood that's 3 feet long, and he wants 3/4 sections, and he just wants to know how many pieces can he get from this board, right? So let's divide and use keep, change, flip. So we have a 3-foot long board, and we want to divide it into 3/4 pieces. So 3/4 foot long pieces. That's where keep, change, flip comes in handy. It's hard to divide this, right? If we were to do long division, it's a little bit tricky, right? But if we use keep, change, flip and use what we learned last week, it's a cinch. So keep this the same, change this symbol to multiplication, and flip or find the reciprocal of 3/4. So let's do it. Keep 3 the same, but we're going to make it into a fraction, but we're keeping it the same. So keep, we're going to change this division to multiplication, and we're going to flip or find the reciprocal of 3/4, which is 4/3. And hey, look, it's just a multiplication problem like we were working on last week. What's 3 times 4? 12. And then 1 times 3 gives you 3. And now it's just saying, it's an improper fraction, but it's saying 12 divided by 3. So if we're going to divide 3 into 12, well, 3 times what gives us 12? 4, which is our answer. So the question was saying that Mr. Roberts has this long board here, and if he wants to get 3/4 foot pieces out of it, how many can he make? He can make exactly 4 shelves, and that's your answer. So what we did is we kept the 3 the same, we changed the division symbol, and we found the reciprocal of 3/4, which was 4/3, and then you just multiply like normal. Let's try some more examples. Okay, so here's example 2. Let's say you have this big old gallon jug of orange juice, right? But if you notice, some of it's gone. About 1/4 of it is gone. So it says Andrew has 3/4 of a gallon of orange juice right here. He wants to pour it into 1/6 gallon containers. So these little containers over here, kind of like mason jars. How many containers can Andrew fill? Same problem, same setup. We want to do 3/4 of a gallon because that's what we're starting with. And we're dividing that orange juice into 1/6 gallon containers. So we have 3/4 divided by 1/6. Keep, change, flip. So we want to keep 3/4 the same, change division to multiplication, and flip, find the reciprocal of 1/6. So keep 3/4. Change to multiplication. Flip, what's the reciprocal of 1/6? 6/1. So we just flipped that fraction. And now we multiply like normal. 3 times 6 gives you 18. 4 times 1 gives you 4. Now this is an improper fraction. We don't want to leave it this way. What we want to do is we want to divide 4 into 18. So let's do that up here. 4 goes into 18 how many times? So 4 times what gets you really close? 4 times 4 gets you really close because that's 16. 18 minus 16 gives you 2. So now we have our answer is 4. You write that big. So 4. Your remainder goes on top, 2. And what you divided by goes on the bottom. So our answer is 4 2/4. But hopefully you see that 2/4 can be simplified. Because if I have, let me draw a circle. Let's say I have a piece of cake, right? I have 1/4, 2/4, 3/4, 4/4. If I eat 2/4, so if I eat all of this, how much of it did I eat? I ate half of the cake, right? 2/4 is 1/2. because 2 can go into 2 one time, and 2 can go into 4 2 times. So to answer Andrew's question of when he had 3/4 a gallon of orange juice, if he wanted to put them into containers that were 1/6 a gallon, how many can he fill? He can fill 4 containers and half of a container. Now, nobody's going to fill half of a container, but he can. Let's try one more example. All right, so let's try this one. Now, this one's going to be a little bit more tricky because it involves a mixed number. So it says Lillian hikes the trail in 4 hours. She hikes the same number of miles per hour. So every hour she's hiking the exact same amount. How many miles did Lillian hike each hour? So here's what we need to do. If you look over here at our sign, it says the hiking trail is 15 5/6 of a mile, right? So that means we want to take 15 5/6 and we want to divide it by the number of hours that Lillian had hiked, which was 4. So 15 5/6 divided by 4. Again, it's going to be a little bit tricky, right? But just like when we were multiplying fractions, you don't want to leave mixed numbers. You want to change your mixed numbers to improper fractions, and then you can start to use multiplication, or in this case, division. So let's change this 15 5/6 into an improper fraction. 6 times 15 gives you 90. 90 plus 5 gives you 95/6. So now that we have an improper fraction, we can set up our division problem. Keep, change, flip. So let's write that at the top. We're going to keep this stuff over here the same. We're going to change the division symbol to multiplication, and we're going to flip this 4. So if I do that, keep 95/6 the same. So 95/6 stays the same. I'm going to change this to multiplication. And what's the reciprocal of 4? Well, if it's 4 over 1, flip it, it becomes 1 over 4, or 1/4. And now I can multiply just like normal. Thankfully, the 4 is on the bottom. 95 times 1 is just 95. So we lucked out there. 95. 6 times 4 gives you 24. So now what we need to do is we need to figure out 24 goes into 95 how many times? So let's do division for this. 24, how many times does it go into 95? So if we think of multiples of 12, it can help us with 24 because 12 goes into 24. 24 times 2 is 48. 24 times 3 is 72, so we're getting closer. 24 times 4 gives you 96. And 96 is just 1 too many. So it's not 24 times 4, it'd be 24 times 3. That's what we're going to have to use. 24 times 3 gave you 72. And let's subtract. 5 minus 2 is 3. 9 minus 7 is 2. So that means how many miles did Lillian hike? Well, our mixed number here would be a big old 3, because that's your answer is 3. Your remainder is 23. And your denominator is your divisor, which is 24. So I know this sounds weird and it looks weird, but it's 3 and 23/24, right? Which is really, really close to 4, right? So how many miles did Lillian hike each hour? Really close to 4, but it was 3 and 23/24. Let's estimate. I know we're estimating in the end, but let's just see if we're right. Let's think logically. 15 and 5/6 was really close to 16, right? And what's 16 divided by 4? 4. So our answer checks out. It's good because 15 and 5/6 is a little less than 16, and 3 and 23/24 is really close to 4. So our answer is good. Okay, so just to practice, here's what I want you to do. There's 3 problems here that I'd like you to try, and each one of them are similar to a problem that we did in the last 3 examples. So take a minute, look at each one of these, and I want you to pause the video and try solving these, all 3 of them, on your own. See if you can get the right answer, and then press play again, and we'll go over it together, of course. So the first one says 5/8 divided by 1/4. So remember, keep, change, flip. 10 divided by 2/3. And remember, this 10, you want to add a 1 underneath of it. 3 3/4 divided by 9. Remember, you're going to want to make this an improper fraction. Keep, change, flip. Okay, so pause the video, try these 3 problems out, and then we'll begin. Hopefully you gave yourself enough time. Let's start with the first one. Keep 5/8 the same. Change this division sign to multiplication, flip 1/4. So find the reciprocal. So 5/8 times the reciprocal of 1/4 is 4/1. So now that I have my fractions, you can multiply like normal. 5 times 4 is 20. 8 times 1 is 8. You don't want to keep it as an improper fraction, which is the bigger number on top and the smaller number on the bottom. We want to change it into a mixed number. The way we do that is we divide 8 into 20. 8 times what gets me really close? 2 does. 8 times 2 is 16. And when you subtract, you get 4. And that's your remainder. So here's our mixed number. 2 and 4/8. Because 2 and 4/8. And again, hopefully you see that 4/8 can be simplified to become 2 and 1/2. Because 4 goes into 4 once, 4 goes into 8 twice. We're just making this fraction smaller. They're equivalent, which means that they're the same thing, but we just want to make it the simplest form. So this one, the answer is 2 and 1/2. Let's try the next one. 10 divided by 2/3. Keep, change, flip. 10, and we're going to add a 1 underneath so that it's a fraction. Change to multiplication. The reciprocal of 2/3 is 3/2. Let me show you a quick little shortcut. Maybe you've learned this before. Before we even multiply, one thing you can do is you can simplify before you multiply. And the way you do that is you look across the way for top to bottom over here and top to bottom over here. Is there any number that can divide evenly into both a 10 and a 2? Hopefully you see a 2 can. 2 can go into 2 once. 10 divided by 2 is 5. So we just simplified before we multiplied, which saves us a lot of time. 5 times 3 is 15. 1 times 1 is 1. And just like over here, we added a 1 underneath of 10 because it doesn't change the answer. So 15/1 is technically just 15. So there's your answer. Let's try this last one. I want to move me over here. So this last one is 3 3/4. First step is you need to change that into a mixed number, improper fraction. 4 times 3 is 12, plus 3 is 15. So you have 15 fourths, because your denominator does not change. Keep, change to multiplication. The reciprocal of 9 is 1/9. The 9 goes in the bottom and a 1 goes up top. And now I can multiply like normal. Let's do the same trick we did over here. To save us some time, is there a number that goes into 1 and 4? Only 1, so these can't get any smaller. But this 15 and this 9, is there a number that goes evenly into both? Yeah, 3 does, because 9 divided by 3 gives me 3, and 15 divided by 3 gives me 5. Well, now I just simplified before I multiplied, which will save me some time. 5 times 1 is 5. 4 times 3 is 12. And looking at this, is there any other number that goes into 12 and 5 evenly? Besides 1, no, because only 1 and 5 go into 5, and 5 doesn't evenly go into 12. So 5/12 is your simplified form. If you didn't simplify first, what you would have had is 15 over 36, which is good, but then this can be simplified into this, because 3 goes into both of these. 3 goes into 15 5 times. 3 goes into 36 12 times. So no matter which answer you had, this is the simplest form. Hopefully that made a little bit of sense for you. So before we finish for today, one thing I want to show you is what Khan Academy looks like. So this video, of course, is going to be posted right here in week 6, the very first thing you see. And underneath of it, you'll see this extra practice Khan Academy lessons. This big old Khan Academy dividing fractions button right here is a hyperlink. When you click on it, it'll take you to this page right here once it loads up. Wait for it. It took a little bit, so I had to pause the video, but it'll take you here eventually. And this is called Khan Academy. And what it is that you'll see that there's videos that you can watch that go over dividing fractions and any concept really. But in this case, I linked you to only dividing fractions. So there's videos, and then after these 2 videos, there's going to be a practice. Then there will be another video and another practice and another video and another video and another practice. And it's going to keep going all the way until basically a little mini quiz / test in the end. Now, I would love for all of you to try this, okay? Because next week, not this week, but next week, I'm going to give you guys a fractions and decimals test that goes over everything we've learned so far in these first 6-7 weeks, okay? So this is going to give you a lot of practice with dividing fractions. But again, the cool thing about dividing fractions is that technically it's multiplying fractions. So it's going to give you a big, broad review of multiplying and dividing with fractions and simplifying and all of that. Okay, so I would love for all of you to give this a look, watch the videos, try the practices, and give it your best shot. Okay, you don't need to tell me your scores or anything like that. Just think of this as an ungraded homework assignment. That way everyone's getting practice, and it's a good way for you to get a whole different perspective of dividing fractions. Because it's one thing to learn it from me, and then it's another thing to learn it from another educator, to hear it in a different way. Maybe their way helps you better than my way. Because the way I always like to describe math is that there's different pathways that you can take in mathematics to get to the same answer. So if I'm teaching it one way, you might learn it best a different way, okay? So just give this your best shot and then try your best. The only thing that is really graded this week is down here where you see the 1-4 practice problems. And if you're virtual, you'll see the practice problems and the gallery walk, okay? So those are the only graded assignments for this week. As always, class, it was a great time teaching you about dividing fractions. Hopefully it made a lot of sense for you. If you have any questions though, please reach out to me. Send me a message on Schoology and I'll get back to you as soon as I can. I had a big attendance this Wednesday during our conferences. Remember, if you want to join a conference meeting for Wednesdays 9 a.m. to 3 p.m., you don't have to join, but it's a good way if you have a question to pop in. I can go through examples with you, and if you're confused on anything like an assignment, I'm there to help you. So from 9 a.m. to 3 p.m. on Wednesdays, that's where I'll be. Okay, you go to groups, Mr. Dotson's Math Crew, and then you click right here at conferences. And then the conference will be live from 9 a.m. to 3 p.m. All right, so keep up the great work. If you need anything, reach out, let me know. And until then, I'll see you in the next video.